This example is very similar to example 19, which we looked at. And remember that we used a method in example 19 to find the solution of a differential equation. And that was, we looked at a definite integral for the function here, which we'd call little f of x. And we looked at that definite integral being between two terminals. One of them was an x value that you were given. We call that x equals a. Another is an x value you're given to try and find a particular y. So we'll call that x equals b. And we'll also call the y coordinate that goes with this given x coordinate y equals d. Now these two together are a coordinate like that. Okay, so the idea was that we could find a solution y at a particular x, we'll call that xb. It was found to be a definite integral between two terminals. The terminal with the x you were given, which is a, to the x that you were given to find y, which is b, so this one in here. The function f of x dx plus your y coordinate d. And this is where f of x, or little f of x, is equal to your differential equation dy dx. So I'm just going to put a box around that because that's really the formula we're going to use in this question. So let's have a look now. It's pretty much just a matter of substituting bits and pieces into here. So we're trying to solve the differential equation at x equals pi and 4, and solve the differential equation effectively means find y. So we're going to try and find y, and this is when x equals pi and 4, so that's the top terminal that will happen in our integral. The other terminal, the bottom terminal, a, is 0. Our function, f of x, is cos x, and the plus d, which we're going to do here, is going to be 0 because the y here with the x is 0. So what we can do is we can put that into our CAS. So we just go over to our CAS. Let's get rid of the one I've got here. So we'll do integral. Oops. And we put in our function, which is cos x. And we're interested in integrating for x between 0 and pi. So use the little pi button. Pi on 4. And you can see it does your integral straight up and gives you root 2 over 2. So that means that y equals root 2 over 2 when x equals pi on 4 is a solution to the DE, or the differential equation. Now, just incidentally, if you wanted to here, you could do this by hand. So this is using your CAS. If you wanted to do this question by hand, you've got dy dx equals cos x. Integrate both sides. Now it's okay to do this when you can integrate both sides. An example we're going to look at soon finds a function here that you can't integrate. We integrate both sides. Oops. The integral of cos is sine x. And then we've got a plus c. We're going to then use 0, 0, which is a point here that we were given. So that allows us to get sine of 0 plus c. And you can see there that the plus c is 0, take away 0, c equals 0. And you can see there that corresponds really to that guy there, the d. So now we've got y equals sine of x. Now we've been given the point x equals pi over 4. We get y equals sine of pi over 4, which equals root 2 over 2. And that's the same solution that you got here. So you can do these by hand as well, but this is a nice shortcut method of doing these questions, particularly, as we'll see soon, when you can't easily integrate the function in the differential equation.